We have a balance made of a beam and dish. When the dish holds one portion of rice, the balance is in equilibrium. The question asks, what are the conditions needed for an object to be in equilibrium? This is a classic equilibrium question. And there are two key conditions here. Firstly, the resultant force must be zero. And what does it mean? This means all the forces acting on the object balance out and no net force. For the second point, the resultant moment must be zero as well. This means that all the clockwise and anti-clockwise moments about any point are equal. So to sum up, no net force and no net moment for section A. Now the dish is 7 centimeters from the string, and the balance is brought back to equilibrium by adding rice. We need to deduce if the dish now contains the three portions of rice or not. We're also given weight of the beam. So let me write the given, which is WB 3.1 Newton. For the weight of the empty dish, which is 0.64 Newton, the distance between the dish and the string, which is 0.25 meter, and the distance between the center of gravity and the string, 0.08 meter. We want to apply the principle of moment here, which is the clockwise moment is what exactly? Clockwise moment has at the right side we have one portion of rice and the dish. So W of rice plus the W of the dish times the distance, which is DD, the distance from the dish and the string. Substitution. Weight of rice is unknown. The weight of dish 0.64, the distance 0.25. Anti-clockwise moment equals. Here at the left side we have the distance 8 centimeter and the weight of the beam. So the weight of the beam times the distance from the center of gravity. Have a look. So the weight of the beam, as we mentioned before, 3.1 times distance 0.08. According to the principle of moment, these two moments in equilibrium position, it means they must be equal. So anticlockwise, 3.1 times 0.08, which is 0.248 Newton meter equals. The right side, we have W of rice plus 0.64 times 0.25. Divide mathematical here, easy step 0.25 and the left side 0.25 cancel out from the right side. So the left side has 0.248 divided by 0.25, so 0.992 Newton meter equals, oh, here is not Newton meter because we cancel out the meters, so sorry, I made a mistake. So it is 0.992 Newton, and this is W of R, the weight of rice plus 0.64. If I want to know the portion or the weight of one portion of rice, 0.992 minus 0.64, it will give us the W of one portion of rice. 0.992 minus 0.64, 0.352 Newton. Now, this is the weight of one portion of rice. The examiner said, we add rice to the dish until the balance in equilibrium. But here the distance changed to 7 centimeters. Okay, make little rearrangement here. I need to draw the dish but at a distance which is close to the string and adding extra rice here. So this distance, which is maybe 7 centimeter here approximately. I'm not good at drawing at all. So what happened? Only the arrangement happened at the right side, not the left side. So it means for the left side, which is the anti-clockwise moment, the anti-clockwise moment equals 0.248 Newton meter. This one, it's the same. For the right side, we add the dish, the W of dish, which is same, plus the amount of rice, the new one, W of rice, times the distance, which is unknown, which is here, sorry, the known one, 0.07. So divide both sides by 0.07 and this one 0.07 because you change the distance and you add more weight, so more weights or more loads, so as a result there's still in equilibrium here, so you have to change the position of the dish with the rice close to the normal to the string. 0.248 divided by 0.07 equals here we have 3.542 Newton equals the W of the dish plus the W of the rice. So if I want to find out how much is the weight of the rice now, so the weight of the rice equals 3.542 minus the W of the dish, which is 0.64. So the W of rice equals 3.542 minus 0.64, which is 2.902 Newton. Okay, sir. This one is how many portions inside this? Okay, so if you are targeting the number of portions, so think about this number. This number has the number of portions, so this is number of portions times the weight of one portion. Okay, now I get. So 2.902 Newton equals the number of portion, which is unknown, so I'll put n, times the weight of one portion. Just go back, slightly go back here, and just highlight how much is the portion of one rice, which is 0.352. So 0.352 the weight of one portion, so number of portion equals 2.902 divided by 0.352 equals 2.9 on the calculator divided by 0.352, so it is 8.24, which is approximately 8.2. But the examiner here in the question he said it's to choose whether the dish now contains the three portions. I would say no, this is definitely more than three portions. Edexcel, they're asking the students, you have to show us this sign. It's kind of prep school here. So show the alligator. So the 8.24 more than 3 definitely portion is not 8. So the dish contains 8.2 portions of rice, and I show the comparison and the consistency here, a kind of consistent conclusion, and I get 6 marks. If you like the video, share and like and subscribe, and see you next video.